thank you for the invitation. Hope you will see us, everybody, in person next year. And I proposed a session on geomatic applications of to Megaliths and Tumuli. I have some slides to present along my my speech. So I'll pass to them, and I'll try to, from there, start. The session is named Surveying the Past, Geomatics in the Study of Megaliths and Tumuli, and it's aimed to share knowledge and to encounter other researchers that are working with this kind of data in the applied to Megaliths and Tumuli. We have assisted in the last 15 years to a small revolution in the data capture, and that allowed us to make surveys of very thorough and detailed resolution that can give us very detailed images of landscapes, buildings, artifacts, whatever. So we have now tools that work for square kilometers or for square inches. We can go from one scale to another with the same technology, different equipment, but the same technology. And I brought to you some images just to show you what geomatics can do to this field of archaeology. So. We are moving towards a 3D digital world. We have 3D scanning techniques, as I told you, that go from satellites to microscopy. There is a lot of enormous quantity of multi-scale 3D contacts. We are scanning Earth, Moon, and Mars already. This is a 3D model from Mars. Maybe the anthropogenic marks are from rovers and satellites that landed on surface. It's I use these images just to show you that we can be very remote when we say we can scan from the distance. Well, Mars is the most far away object that we have scanned already. So we are using this 3D data to build 3D models, replicas of surface, and we have to use different kinds of visualization techniques, and that's my specialty. It's where I work. It's how to, from this data, create representations that are pertinent and that contrast or highlight the marks that we want to see. So there are a lot of techniques, from wheel shading, from axometric. Some of these techniques come from the old petrographic conventional representations. New, like slope inclination, that give us different image from the same object. It's always the same 3D model here. This is slope orientation. And we can, with all this information, we can contrast small evidence that are within the models, that are implicit in the shape of the models, and that we can make explicit. We are needing new approaches for visualization of 3D point cloud, 3D models from scanning. And as I told you before, it's my area of research. So I've developed a new technique that can be applied to Mars as well as small objects and everything within them. This technique is not dependent on light direction, so it's something that gives us an image that is not constrained by light direction, light angle, and it can be applied to whatever model we found. These techniques are based on trend calculation. We try to shape the trend morphology of objects, and then try to capture, to contrast the small details. This is a session from LiDAR aerial scanning survey from Spain, a work that I did with CSIC and the Incipit lab in Santiago Compostela. And what we are trying to do here is to identify in an automatically way mounds in the Barbanza area. We use an algorithm, this morphological residual model, that using the 3D data can make depictions, contrast depictions of mounts, making them very visible and identifiable in the middle of all the morphology that is captured. These techniques can, if we come closer to the object, allow us to get more detail and more resolution on the areas. This is not a Tumuli and megalithic area; it's a Roman site, Clunia, north of Burgos, Spain. And just to show you a little bit of the amount of detail that we in this image here that we can capture. Not only the archaeological excavations, but all the ancient marks. Most of them are not seenable or detectable, even if you are in the place. And this one comes from all these alignments come from. I don't have it. Came from the use, the agricultural use prior to the discovery of Clunia. So. Portugal hasn't yet any systematic aerial laser scanning of the country, but Spain does, and it's been quite a field of research, quite a huge amount of data for researchers in several areas, and also in archaeology. It's free, it's online, and it's very, very interesting the way that Spain used this data, not unclassifying it and making it available to everybody. What can we do with this aerial laser scanning? We, especially in areas of vegetation, of forestation. This is an ancient Roman mine, secondary deposit, alluvial, that was forest in a very systematic way, and the 3D data that we capture from aerial vehicles with the laser scanning allow us to capture everything, the trees included, but we can discretize what information we want. We can select only the last returns of the laser beam and be able to pass from an image like this with all the vegetation to a cleaner view of the soil, of the ground. It's a really a digital terrain model that shows us a lot of features and details on the excavation on the site. So if we just to compare, this is what aerial photography can give us, and this is what aerial laser scanning is able to provide us in forest areas. So it's very, very high potential technology for archaeological prospection of very large areas. This is another filter. There is a very funny story. I was working with Lara Bacelar in a site in the north of Portugal, and we were working on a field on a survey of rock art, and I had the idea of well, let's see if Spain has. Let me come back. If Spain, if the aerial survey of Spain has some information about this site. The funny thing is that to be able to capture all the border data, the Spanish Geographic Institute has made a little bit of survey of also Portugal. So we are using this strip, this last points from the scanning to help us to find things. And in this Monte Faro area, we have spotted something that can be an ancient construction. I don't know if it was already explored or not, investigated or not, but a very particular form in the landscape. It's about 300 meters wide, so not detectable in aerial photography. What you see here, it's an orthophoto from that area, and colors are not useful for this. It's shape detection. So we are trying to use this this kind of data and to allow for detecting ancient structures that are no more detectable at plain sight or even with aerial photography. Another interesting branch, and I'll be very quick just to finalize this, it's we can really scan the past because we have data from the past. Just after the Second World War, there was several campaigns of aerial photography aimed to make a systematic cartography of in all Europe. The Americans start with it, then the British also made a survey, and the Portuguese authorities also made a survey. So we have 3 campaigns for Portugal. For the rest of Europe, there are also several campaigns from the 50s and the 40s of past century that allow us to reconstruct the shape, the texture of what it was, and so we are in this particular field. We are really scanning the past because we have data from the past. It's very interesting. This campaign of aerial photography made a record for all the countries, so it's very systematic. And all this data is lying on basement on the Geographic Institute of the Army, waiting for researchers to look at it. Going to more detail, this is more detail insight. This is Alvito Alvito. I don't. I just forget the name. The mound, the dolmen of Alvito, and this is a 3D film, a 3D movie that was made from the model that we have captured along during one of the field campaigns. So we can represent the detail of each of one of these sites and share it with internet or other sites. We can also use these technologies to recreate buildings, monuments. This one, it's a very big dolmen in interior of Portugal. It's Carapito, and all the small pieces that are colored in this model were found in the neighborhood of the dolmen, and before it was reconstructed. It is being reconstructed right now. Before it was really reconstructed, we have tried all the combinations, the positions of the fragments, and made 3 complete anastylosis. So we can go even further. We can look at the surface of the construction elements of the monuments and use these techniques to spot rock art. We can see here two elements, two graphic elements on this orthostat from Alvito. We can even solve very tricky problems like how can we represent how can we record, how can we identify the details of rock art in the surface of a megalith like this. And so we use 3D to capture the morphology of the surface, and we use these visualization techniques to contrast the grooves. For instance, we can see that there are a lot of irregularities around this side, but when you contrast them, we can see more details, and well, it has been a big help for archaeology. So this was my introduction to the team of the session. I'm available to answer to your questions, and we are hoping to get a lot of researchers inscribed in this this section next year. So, thank you.
I would like to ask you something. So we can. I have two questions actually, or comments. We can do. So the question is, we can do this whatever the scale, right?
Yeah.
So we can do this on artifacts themselves, right? To see details in the artifacts. So that's very important.
Marks.
Exactly. That's where I was getting to. And the other is, sometimes what I find is that, you know, the 3D models that you show, of course, the lead artists are those that are very good because, you know, it's obvious you take the images and process the images, and you can find things that you can be walking. It's like I had a professor that said that sometimes when you are looking for something that is very big, you are on the top of the site, you are not seeing it. Exactly, right? And you used a very good expression that it's like being with a magnifying lens in the back of the animal, of the elephant, looking to find an animal, some kind of animal, and you're in the back of the elephant. And so those are, but my concern is more when you do the 3D, when you know, people do the 3D model of the sites. Of course, it's very good because you have that represented, you have that reality represented at that point, and eventually, if you are excavating, that will be removed, and that's the way that you have very good information and representation of what was it before you excavated. But what I feel is that for the effort, the quality, and the cost, the data that you can extract from that, and how can you can link it to the the other data, it's not very explored. So in which ways do you think we can be more go forward in this? You know, having the 3D model and instead of being just a a cool image to show on a presentation, you can use that and say, see, because you do this, we can extract this information and link to other things.
Yeah. Well, I usually I didn't talk about this because it was a very quick presentation, but I usually try to frame these techniques in a new paradigm of surveying. We have changed with these scanning techniques, whatever they are, the scale of it, underwater, in the moon, wherever. The scanning techniques change a little bit the way we do surveys. We go to the field now, and we don't decide what we want to survey. So instead of like with previous technologies, GPS, total stations, metric survey, the quadrical method for archaeology, all this information was captured in a very interpretative way. It means that the surveyor or the archaeologist or whatever was taking the measurements, he decided what measurements to take before. So it was a more cost effective in the sense that you decide, oh, I want the height of this megalith, or I want the volume, or I want a simple measure, and you take these measures and you work with them. With this technology, the scanning, the 3D scanning, we have changed this paradigm. And when you are in the field, you don't choose what to survey. You survey everything, and then the interpretative work is done afterwards. It can be done in the field, or it can be done in the office. It doesn't matter, but we are really changing the way we work with information. There are advantages and disadvantages for this, as you told. There is a cost with this technology. Sometimes that is very heavy if we are talking about planes and laser scannings in the air and everything. But as we apply this to more fields, more area, there is a market reaction, and the price is coming down. since it began. We have taken 1 or 2 zeros from the cost of using laser scannings and all these techniques.
Of course. Those are always good news, of course.
Yeah. It's moving forward. Well, the first laser scanner I've rented, it costed almost 4,000 euros a day, so it was 20 years ago. Now with 4,000 euros, I almost can buy a laser scanner, not yet, but we'll get to it. So there is this change in paradigm, in surveying paradigm, that is very important to note, is that now we can have a replica of the site, of the entire site in our computer, and we can analyze from there. We can apply several techniques, like visualization techniques, like I didn't work with that, but I worked with some researchers in finding least cost paths on travels in the territory, and we can use for that very detailed models with all the outcrops, with all the tracks, with all the very small details on landscape that can really inform this kind of analysis, like least cost path, visibility, whatever. So it's what you say. It's a pertinent. Your question was very pertinent in the way that does this really help us to find things, to detect more things, or is it just a way of doing beautiful pictures or nice pictures to put on the cover of the project? I think it can work for both sides. It's really very uncoded the images, so we can show these models to kids, to people that live in the area, so we can share it's information, uncoded information, more or less uncoded. It's apprehensible by non-techniques, non-specialists. So I think that's where what we are, all the people that is working in this area, trying to do is to give tools. There are more tools than the objective in it itself. So I think we are in a very good moment, because we have a lot of results, and I hope the session that we'll have next year will be able to show that and to share this different approaches.
Yeah, thank you very much. Let's go for a short break and continue with the next session in a few minutes. Section 9, Measuring the Time of Burial Structures, Searching for the Oldest Dates, by Pedro Proença Cunha, that is in Denmark at this point, in the beautiful landscape. So see you in a few minutes.